Okay, well, we can start, right? Everyone, I think all are joined. So today, uh, we are going to learn application tiles. Okay, when coming to application, I mean production application or testing application, any application, we are combines with the different tiles. Okay, so so there is a application. Okay, different way we can architecting application tiles. Okay, so which one tile, two tile, three tile. Then there is a lot of tile. Okay, like as per the requirement, we can add up more tiles. Basically, commonly we can see two tier and three tier applications there. I mean, application tiles there. And what is anyone know the tiles, single tiles, double tile, triple tile? Any idea? Anyone?
A desktop application can be treated as a single tier application if it will just work with file system.
Yes.
A desktop application which connects to a database can be treated as a two tier, or a batch application that communicates with the database can be considered as a two tier.
Hmm.
Or a website which relies on a web service as well as a database can be considered a three tier.
Hmm. Okay, right. Consider this is a mission. Okay, this is a mission. And inside the single machine, okay, inside a single machine, we configure application. This is application, okay. This is the application front end or the UI, user interface. Yeah, front end is fine. Front end. This is a front end UI, and there is a database we configure in here, okay, inside that here, and we configure that with the database, okay. But the both are relies in a single machine, okay. This is a simple example of one tile because all are wrapped up in a single machine. Then coming to next scenario, two tier application. This is the oldest model. I mean, traditional way we, for example, we have a single machine like desktop machine. Then we configure uh, web server. Then we, I mean, provisioning the web application. Okay, that's a example of a tier one application, and we can set up the database inside the single machine. Coming to two-tier application, we took two machine, okay, for coming to two-tier. So the front end will be here. This is the front end machine, and we create a connection between the front end machine to the back end machine. This is called back end. Back end machine. Okay. This may be database DB. Okay. This architecture, I mean, this architecture is two-tier. Coming to here, why we choose two-tier application. For example, we can get maximum scalability, maximum availability. We can, troubleshoot easily, and so many. Coming to maintainability, performance, all things we can, coming to this two-tier, we can improve these things like performance, maintainability, scalability. Now we are going with the three-tier application. Three-tier application basically, I'm audible, right?
Yes.
So, yeah, this is the front end. Okay, this is the three-tier. Again, we segregate another resource. Okay, I mean, for example, coming to real world, we configure 3 machine. Got it? And I will explain with this is the front end. This is one of the machine. Okay, this is machine 1, and this is machine 2, and this is machine 3. So first machine we configure the front end. Okay, front end application. Then the second machine, there is a mediator. Okay, this is a mediator, and most probably the mediator belongs to application layer. Okay, I mean application tier, or like we can say this is presentation layer. Okay, the front end is presentation. I mean the user interface. This is a abc.com website. Okay, abc.com. So the user first hitting through the network and access the front end. I mean the presentation layer. Here the user surfing and all the things. Then there is a second tier here that is called application tier. Okay, here the business logics and so many things happen here. Okay, so like for example API, we can consider API. Nowadays, by coming to microservices, we configure API as a second tier. Okay, I mean the immediate. Then the third tier. This is most probably data tier. I mean the database. Database. And most probably, most scenario, we keep this tier as private. If you configure application cloud, this is the private subnet. Okay, and these two are in public, API and the front end. And coming to Kubernetes cluster, how we configure the database, the service, anyone? coming to, we deploy a three-tier application in Kubernetes cluster. Okay. Kubernetes cluster. And we didn't expose this database tier to the public. So how we configure in Kubernetes? How we set up the thing? All of you. No idea? It's a easy question. My point is we don't expose the database, got it, to the public. No idea. It's simple. We have a service for the database, right? So in service, Kubernetes, okay, service.yaml. And we didn't choose, we don't choose load balancer or node port. We keep as cluster IP, only internal communication. Got it?
Can you repeat for me, please?
Yeah. For example, we have a database, okay? Database tier in Kubernetes. And we didn't expose to public. Got it? Similar way, we are configuring the three-tier application in AWS infra, okay? AWS infra, using VPC, subnet, EC2 machine, okay? So the hierarchy will be like this. This is our VPC, okay? So this is our tier 1. This is our tier 2. This is our tier 3. Anyone know what is this tiers? How we segregate tiers? Using one component called subnet. This is subnet 1. This is subnet 2. And this is subnet 3. And these two subnets are public. So first 1 and 2. And the third one for the database, third one will be private subnet. And we configure the NAT for accessing the thing, I mean, integrating and add routes for accessing the different types. I mean, the 2, 3, 2 and 1. We configure the routes in route table. Public, this is public, and this is private. This is front end for presentation. Got it. Coming to Kubernetes. We configure this the same way, and we create different pods for different application. Okay, like yes. These are pods, okay. Pod 1, pod 2, pod 3. Pod 1. Two. And this is pod 3. And this is the front end. Front end. This is the API or application. This is database. We configure SQL, MongoDB, anything in the pod 3. I mean, this. And for each pod, we create service. Service. This is like load balancer, okay. Load balancer, LB. This also in load balancer. As per the requirement, we need to change, okay. Load balancer. And this is service for the database, and type is cluster IP. Now we can say our database is secure because the database is, I mean, that didn't expose to public, I mean, to internet. I mean, the user can't directly hitting our database. Got it. So in top of service, there is a load balance. Okay, I mean, this is a way hitting. Okay. Any doubt for the architecture? Anyone?
For the part 1 and the 2, can't they use only one load balance? Okay.
Yes.
Okay.
I mean connection. This is for accessing the AP. Okay. I mean actual connections. I mean from outside. This is a user and coming to the load balancer. Okay. Then accessing the application. This is abc.com or this is a this is the application like abc.com. Okay. So first hitting the load balancer, then go to the service, then it will route to the application. Here the container is application container here. Okay. So the user can access the front-end application, and if anything related to the database or some data will store in database. Okay, I mean there's a form or anything. Then I mean some queries there. I mean to getting some details of some product or anything, we need to get the database detail. Okay, so it will go to the AP, hitting the ATP. Okay, I mean the user need to access some data from the database. Okay, here the database. So the API will hold the required data and gives back to the front end. Here the mediator is API. And there is no direct connection from this request to the database. Okay, only through the API. The next talk will API, and API go to here and take the thing and get back and give the detail to the user. And this is called microservice. The front end will be written by Python, backend another language like each microservice means this is one microservice, this is another service, this is another service. Okay, coming to a full-fledged application, there is lot of microservice like 10 service or 100 times service or 1,000 service of microservice there. Okay, as per the size of the application, like coming to big giant application like Netflix or Amazon, Flipkart, that applications have lot of microservices. Okay, so each microservices written by different languages. I mean the programming languages. One is Python, one is C Sharp, C, any app, any code we can use, any language we can use for developing the small microservice application. Then we need to integrate each one. Got it. You know the service type, right? Microservice and monolith. Anyone? Monolith and microservice. Don't know.
I think they use one server for monolithic and they put everything together. And anytime there is one crash, I think the whole application is down. So for
Right.
microservices, like one side can stop working, but others can continue running because they use different servers or multiple servers. That's the way I understand it.
Right. Okay. Monolith is a traditional architecture. Okay. I mean, previously we deploy application. I mean, traditionally we deploy application using the monolith architecture. Monolith means it's a architecture is in, I mean, approaching where an entire application is built as a single unit. My voice is breaking, right? Now it's clear, fine. I hope fine. Yes. So yeah. So this is the monolith application. For example, this is a application, okay, a e-commerce application, and the entire application language is single. I mean, entire application written by a single language. For example, this application written by Python. Okay. So, and we couldn't change, okay. I mean, at the start, which language we are written for the application, we couldn't change at any time. That's one of the drawback. And all components such as user interface, business logic, and data access, any components are combined in a, I mean, into a single code base. That's called a single language. And monolith typically easier for developing. I mean, initial stage. Initially, we can complex. I mean, become complex and difficult maintain as the application grow, because we only concentrate a single code in a single language. So coming to microservice, and here the debug is one of the main problem. Okay, I mean, there's a lot of, I mean, thousands of lines with a single line. I mean, not single line, single code, single language. So if you face any, I mean, this is as per the developer's perspective. Okay, I mean, if anything face, I mean, application bugs or anything, we need to dig more. I mean, with a single application, there's a lot of code that will make complex thing coming to microservice. Sorry, monolith service. And yeah, these are the basic thing. Coming to microservice, I mean, coupling. I mean, there is small service. Okay, we segregate small service, but this all small service work as a single application. Okay, for example, this is a front end, and this is a database. This is API. Here the payment gateway. Here the cart or anything like that. Cards, and yeah, lot of service we can consider here. Okay, like media streaming or anything. And each service is written by different language. I mean, this is Python, this is C hash. That's not a problem. Okay, we can add more services here with the different, I mean, some other language and integrate with the service. And we integrate all the things, okay, as per the requirement. For example, the front end will communicate with the streaming service, then we can connect that. Then the card, all things we can connect. So here the one of the major benefit is if any service is down, okay, this service is down, our application is running, okay, but we couldn't access this specific service, but other service we can access. And in the meantime, we can check the problems and roll back the thing. Okay, I mean, what happened, then we can reinstate the issued the application, I mean, service. So nowadays we are going with the microservice, you know, That's why we are using what? Which service? Containerization. Because each service is run in a container, right? This is container, this is container. In Kubernetes, this is a pod and the application runs in a container. Got it? And one of the most example, Netflix. Got it? Anyone have a doubt? So we can jump into the lab. So there is two scenario. One, I will go with the E case. Okay, that will more suitable for, I mean, DevOps engineers, because as a cloud engineer we can set up the thing in AWS console. Okay, configure VPC, subnet, and configure EC2 machine, configure database and all thing, and I mean call up each things. Okay, I mean from one tier to another tier. So as a DevOps engineer, we are the one who perform these application tiers and all the things in Kubernetes. Okay, most probably we are working Kubernetes architecture. So I am going to spin up one Kubernetes cluster, and now now I am going to configure a Kubernetes cluster in console. Okay, previously we configure the thing using CLI, I mean command line on the thing. Now I am coming to the console, and this is my AWS console. Then I'm going to EKS. Now I am in EKS, but I'll show you. Yeah, now I am in EKS. Here we can select add cluster, create cluster. Okay, this is the way how we create Kubernetes cluster in AWS console. Okay, first we need to give it a name. Anyone know what is the latest version of Kubernetes? One point 2.9, 2.8. Okay, this is the latest version. And we need to provide a cluster service role. I configured one service role, EKS cluster role. Okay. We covered this section. Okay, go to IAM and create a role and create a policy. Okay, the policy is EKS cluster policy. There's a policy under EKS cluster, and choose the policy. So I will show you my policy. EKS cluster policy. Sorry, that's the code. EKS. This is a role. Okay, first we need to create a role. Create a role means nothing. It's a role, but when the role is active, I mean, we need to specify the permissions. Okay. First, we need to create a role. Then the role, this is a role, and we need to create, I mean, a permission, give the permission. Here we can add permission, I mean, add policy. So here I am added two policy. One is Amazon EKS cluster policy, and the next one is Amazon EKS worker node policy. these two policies I attach to the role. So this is a role, EKS cluster role. So choose the same role here. And yeah, leave it as next. Here we need to choose our VPC, okay. When we try with a single command like using ekctl, create cluster, then the cluster name, the region, the node group, all the things. That's an easy process, right? When hitting the enter, it will create all the things like VPC, subnet, all the things, load balancer. When we are going with the console, we need to specify all the things manually. So here I am choosing my corresponding lab and the subnet. Ensure that there is two subnet we need to choose, okay, and each subnet will different availability zone. So make sure that all of you tomorrow, same time, all are available, right? If available, then I can take the pending. There's one pending class there. So just ping me in group, okay, after section. So here I am choosing the available zone that's under the same VPC. So I have two available zone and each one in different zones, okay? Like one is 1F, USC is to 1F, and another subnet is USC is to 19. So I'm choose both. Then why we choose the both? I mean, from different available zone. Anyone? Because if any available zone is in, I mean, in like issue or any calamities issues or any network issue, power failure issue, anything, our data is in the next available zone. Okay. That's why when creating EKS, we ensure, I mean, the AWS ensure we need to choose at least two available zones that will be in different availability zones. I mean, subnet with the different availability zones. Okay. Then security group, we can choose any security group. Then cluster IP address family, we can choose IPv4. And cluster endpoint access, we can choose the public because this is public EKS. And click next. Here we can add configure login, control plane login, or thing like API server, audit, or authenticator, control manager. By default, we can go with the disabled. As per the requirement, we need to enable. All are for the logs, okay. These are the add-ons, okay. The core DNS, Amazon VPC, CNI, and Pure Proxy. These are the add-ons, and these are the three add-ons. By default, it's installed, and we can go with the next. So these are the versions. I mean, that add-on versions. By default, it's 10.1. You can go with the default versions. Not the default version. I think that's the latest versions. Finally, we can review and create. These are the things we configure and create. So it will take some time, around 15, like 10 to 15 minutes will create. now we are creating the cluster only, okay? After that, we need to create or configure the node loop. The worker machines and choose the machine type, machine image, and the desired state of machines. Then we need to add the machines, okay, to the cluster. Meantime, I'm going to add one more add-on that is called AWS EBS CNI, okay. It's an add-on for adding storages in our worker nodes. Get more add-ons. That add-on is not in here. This is the add-on configured. And yeah, this is add-on Amazon EBS CSI driver. Enable Amazon Elastic Block Storage within your cluster. Choose and next. Choose the build version and here the AMP role. You can choose insert with the node. Okay, again I'm choosing. Next. Choose the inherit from node, okay. So what are the roles we are in provided to the node? It will inherit to the add-on. Create. And now this the add-on EBS will add it to the cluster. See, status is creating. All are tried the Terraform task, right? All of you. Okay. Anyone face any error? Fine, Jay. See, under Kembut, there is nothing. Zero node. This cluster doesn't have any node. Okay, see, now our processor is active. And I will go to Fireball. Now, what will we do? Like, I mean, we need to add compute. Okay, so that go to the compute. Here we can see there is a option called node group. So here we can add node group. So use that node group, util name. This is for my group name. Okay, you know when we are configuring EKS cluster using the command line, we provide the node group name. Same way we provide here my node group. And here we need to provide a IAM role for the node group. So here I already created a role for demo role for the node group. So this is the role. So I will show you the role. Demo role. So this is I created a role here and attach some policies. The policies are Amazon EC2 container registry read only. That is one of my policy. Then Amazon EKS CNI policy and Amazon EKS worker node policy. These three policies I attach to the role demo role. First I create a role, go to role and create a role. Then choose this policy. And this is for the case. Okay, I will create one more thing. Choose the AWS service, and the use case is EC2. Then next, here we can add the policies and add that 3 policies and next and create. That's all. That's done. So here I am choose the same policy. Then yeah, leave it all. Next, this page, see non-group Kembed configuration. Here we need to configure the mission details. I mean mission type, mission capacity, instance type. I mean the family of the instance, the disk, the storage of the machines. And coming down here, we can see the scaling configuration here, desired state, the minimum state and the maximum state. We can specify here. Okay, so I am going with Amazon Link sale to this machine, and capacity type is on demand. Then I am changing to T3 medium to T2 medium. T2 medium. I am choosing T2 medium. So my disk size is 20. So I got 40 GB. Then my desired set is 2. I need 2 node. So I am between 2 only here. Then next. Here we need to choose the subnet. So in my case, there is 2 subnet that all will automatically fetch here. So choose that 2 subnet. Ensure that here coming here, okay, these 2 subnets have, I mean, we need to enable the IP auto assigning public IP. Otherwise, we will face some error here. So I will show you. Go to VPC. Subnet. By default, that is disabled, okay. Otherwise, when we at the time of creating subnet, we need to configure that thing. I mean, enable that thing. And don't worry, after we need to add that enable IP option. Meantime, I am going to create here, okay. I mean, adding the node. Next, this is a review. Then go to down and create. So the machine will configure here and add to the cluster. I'm audible, right? subnet. Okay, these are my two subnet, okay, in my corresponding VPC. So when you are configuring, just enable, how to enable, I will show you. Choose the subnet and edit subnet settings. See, by default, this option will be disabled, okay. Auto assign IP settings. I mean, under this option, I mean, we need to enable auto assign public IP address. This will be enabled, okay. If this is disabled, we couldn't create node, I mean the nodes in the Kubernetes cluster. Got it. If we enable this, when not in EKS perspective, when we configure EC2 machine, Kubernetes, I mean in AWS, we didn't. There is no option like enable IP or this as public IP when we configuring EC2 machine. This will point to that creation. I mean, it's automatically we will get public IP. So here, not, yeah, this is under creating. See, not ready. Yes, one machine ready there. Hold on. If any issues with the node group, we will get a health check here. Any health issues here. So this state is 2. One is up and ready and still under creating. See, and the another one is hitting here. It's not ready. And we can see in our instance page here. See, yeah, these two, I think. One is this and this, sorry, this one. Both are under initialization and the type is T2 micro, I mean medium. These two are our nodes. Yeah, it's now pan running. See, now our Kubernetes cluster is fully active. So this is the way we create Kubernetes cluster and I mean through console. So this much time it will take, okay, going to each scenario. That's why we are going with the control, I mean the command line to configure the cluster. Then there is another way we can speed up the creation of the cluster using Terraform. the single command, we can configure the Kubernetes cluster. And check the add-ons. Okay. See, core proxy is active, VPC is active, Amazon EBS CSIS driver is active, and core DNS is degraded. So ensure that all add-on will be active. Okay. And what is the purpose of kube-proxy? This is enabling networking within our cluster. Okay. Same way, Amazon VPC is enabling for networking within our cluster. And this is for elastic blob storage. What is elastic blob storage? Anyone? EBS.
That is for storage.
Sorry.
Is that for database storage or the storage hard file storage?
I didn't get you. I mean, breaking.
The elastic block storage is for either database storage or
Simple way, it's nothing. Okay. This is our PC, desktop. This is the CPU, right? So CPU have the drive, CD drive, and the motherboard, inside motherboard RAM there, and we need to store our data, right? That is called hard disk. Right? Coming to cloud AWS, we configure virtual machine, right? VM. And choose the AMI network, all things we specify. After that, there is an option called EBS. EBS is similar thing, I mean similar kind of hard disk, okay? The storage. We configure in this Kubernetes case, we configure EBS for 20 GB. Here we configure hard disk for 1 GB, 500 GB like that. For this mission, we configure hard disk for 20 GB. So, and we attach the EBS to the corresponding machine. So EBS is a storage device. Most probably it's a hard disk or SSD. Yeah, hard disk. Got it. So this add-on is for example, this is our cluster, Kubernetes cluster. So using that add-on, we can manage and configuring storage, EBS storage. Okay. For example, here we have one pod. Okay. That pod running, I mean, that is a database. Consider this is a database application inside a pod. So here this pods needs some more storage. Okay. So what will we do? Create a 1 GB storage for this database. Why we configure this 1 GB? I mean, for example, if this pod is dead or the container is down, our data, I mean, the database data are in this storage. For that purpose, I mean, some scenario like this, we need to configure storage outside our cluster. If our entire cluster is down, our data is saved in our EBS. Got it? For that scenario, we need to add on this EBS add-on here. And here you see one is degraded. So we need to go there, degraded, edit, select all, right? Load it. Sometimes when we load it, then here it will success. We'll wait and see. Nothing happened. Just save changes. It will, the state is in progress again. I think now it's done. Yes, it's updating. I think it will be success. Refresh. Yeah, it's active. See, ensure that all add-ons will be in active mode. Okay. Sometimes when we creating at the first time creating, if we add the add-ons, it will make degraded like that. Which I mean, it seems like degraded. Then go to the specified add-on, and once again we need to save the thing. Then it will back to the active state. Got it. So now our cluster is up and running. So now in my case, there is some configuration files. Okay. I mean, some manifest, deployment manifest there. See, these are the manifest I have, I mean, in my GitHub repository. And yes, this is for the API deployment. This is for the front-end deployment. This is for Mango database deployment. And this is for secret, okay? And this is for service. This is for Mango stateful set. And all the things we will go through each one, okay? For the coming section, we are going with the deployment. I mean, creating the three-tier architecture. Here we have three-tier, okay? One is the AP is the middle tier, and the Mango is the third tier, and front end is the first tier. Here we are going with the MongoDB as a database. And for MongoDB, we create a service secret.yaml, and we will learn two terms in Kubernetes, that is secret.yaml and stateful set. Okay. Fine. All of you. And kindly inform tomorrow availability, okay? For all are available tomorrow, then we can sit the same time. Just inform me in the group. Okay. Then we can wind up, right? All of you.
Yeah, yes, sir. From my
Okay.
side.
Tomorrow availabilities, please everyone reply me in the group. accordingly, we can take the section and yeah, go through the three-tier application deployment in E case. Okay. So for this lab, you can learn so many things like you see the stateful set, how the stateful set works, how we keep seekers in the given cluster. Then yeah, API, so many things. These are the new things, okay, for you. As of now, we deployed the deployment YAML, service YAML, all those things, right? So when coming to this lab, we will learn API and secrets, then stateful set, all the things. Got it. Then we can wind up, right? Okay. Then okay, all of you. Bye. Bye all.
Thank you, sir.